Well, this is Robert Daniel Smith again, and what I'm going to do is we're going to look at redesigning jet engines. I was a boilermaker, worked for Arizona Public Service, also a master chimney sweep, I also had a body shop, mechanics, everything is mechanical in my life. Machinist, I did many trades. Pipe fitter, plumber, you name it. And what we're going to first talk about is water. I worked for Four Corners Power Plant, and they had several different boilers there, 5 of them all together. But the one that was very important was made by B&W, a once-through boiler. And what they did, there's no steam drum at all. You have to have a steam drum on a regular boiler, and the water is generated up, bubbles are generated up the walls and collects in a steam drum, and from there it goes to superheats and so forth, and then to steam turbines, which turns a generator. But B&W made a once-through boiler. There was no steam drum. And being a chromoly welder, I had to know everything about this B&W boiler. It's a once-through boiler. And they put probably around 4,000 PSI of water, ATERN, and they ended up with 36 PSI at 1000 degrees. At this state, it isn't water and it isn't steam because it's never gone to atmosphere. Water is a state of matter. By doing this, what they did, they changed matter. It's not steam and it's not water. They went to a third stage. Correct my spelling if I spell it. Third stage of matter. It changed water completely. I dealt with engineers a lot, and I found most of them didn't know their ass from a hole in the ground. They always put me with engineers because I knew more. Do not have degrees, but they made third stage of matter. It wasn't steam and it wasn't water. It was something else, totally. And I seen steam blows. Right before the turbine, they did steam blows because we put in all new superheats. And out the top of these 12-inch lines that came off at the turbine was an envelope, like a gas flame, burning the hydrogen. This is very important, and they only made two at Four Corners, two at Mojave, and they were very massive. The boilers were roughly 12 stories high. The superstructure of the boiler was 12 stories high. Inside the boiler was 80 feet by 60 feet, 10 stories high. That was the firebox. But the most important thing, what they did, was they changed matter. And it isn't steam, it isn't water. When released to the atmosphere, perfect blue flame, burning the hydrogen and the oxygen as one, just like a gas stove. And they did not know what they created. This is very important. I've seen it, and there's also a 4-stage. Seen it right after it splits into 4 lines, 12-inch lines. ID inside diameter was say 12 inches. OD was 17 inches. Two and a half inches or better of 2 1/4 chrome, C-R-O-M. I don't really know how to spell it. And it happened. Wasn't there when it happened to the 4-stage. It took the line and blew it up like a snake. The line, like a snake swallowing an egg. Incredible. I think there's a 4-stage. They said if it had erupted and the insulators found it, taking off all the asbestos insulation, because I lived in asbestos, and it festered. But when they took off the insulation, they found it, and we had to cut the line here and here and replace this section to make it all one again. And I was in line with a bunch of other Boilermakers taking turns welding. It was a continuous weld. Yeah, I had to keep going and going and going. But if this didn't hold it, I don't know what will. Kind of strange for one section. They said if it had released inside the building, which was roughly the size of a football field and 4 stories high, there would have been nothing left. It would have obliterated the whole thing. The only thing to be left would be the turbines. And I believe them. I think there's a 4-stage. Not sure, but I've seen the results. If this didn't hold it, nothing will. It might, usually when they build lines, it's got to hold twice or 3 times the pressure. Like a snake that swallows an egg. I mean, it was amazing. I was sitting there looking at it. It was all crazed. It was sitting in the shop. So this is important. And important to the world, because now we know how to make something. B&W did not know what they made. They're turning $750 megawatt turbine made by General Electric, or as we all say, GE. Massive. It had 2 different ones. I'm going to draw it up here so I know it gets it on there. one generator here, the other one here. And when it came through, there's a high pressure, which then go back to boiler, gets reheated, then it goes through the intermediate, IM, and then it crossed over to the LP. Massive. Last stage of this, the first fins were this long on the turbine. That's how big they were. Then as the energy is used up, they get smaller, 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 bigger and bigger and bigger. And the last stage of the turbine, I'm going to draw a turbine. The last stage on the LP was 24 feet across. I stepped it off. It was in the crane bag. Amazing. Absolutely amazing. No one builds a boiler like B&W. I mean, it's their mine. The only problem was they gave it to Arizona Public Service. It had no mine. They cause many problems. People think they invent things. They do not invent things. I'll change this, and they create many more problems along the way. Instead of calling the manufacturer and asking them, well, what does it do? They just say, well, we think it this way. And that's a problem with this whole system of thinking. B&W would have ran the boiler by itself. I've seen this happen time and time again. They didn't get back to manufacturer. They didn't ask any questions. It's better to ask questions, go back to manufacturer. People add things to books for no reason. They create more and more problems. GE builds the best generators in the world. At this pressure and this temperature, it's massive. And it's the third stage of water. This is very important to know. And of course, you're going to have to fight B&W for the answers, which they didn't see. So let's go a little bit further with this, because we're talking about jet engines. And once I've gotten you through this part, you'll understand the rest. And by the way, when they're doing steam blows, I was on the ground. This is 5 stories up in the air. And it literally shook me to death. They had people up there working by it. I can't imagine. I've lost most of my hearing from vibration, not by hearing, by being shook. I've walked in pulverizers that the water jumped off the ground 4 inches. Vibrations. It doesn't matter if you hear it or not. If you're vibrating, the same thing will happen. So I'm going to shut off, understanding what happens at this pressure, and also we'll talk about people who I learn things from. And then we're going to go into jet engines and basics. What is a jet engine? And understanding what is better. Okay, in this section we're going to talk about jet engines. And you see them, they're kind of round, you know, on every airline. And before you get in, you can see the compressor blades turning. The reason for that is because of heat. These things are so hot, if you shut them off and didn't turn the shaft would bow. I've seen it done on the HP side of Unit 5, where they got water back into the HP turbine, and after they shut it down, and it warped the whole shaft 87 thousandths. 87 thousandths. When they started it up, they couldn't turn it, so he hit it with 3600 psi at 1,000 degrees steam, and he could only turn 1800 RPM. 1800. Thing should turn at 36. It was shaking the books off the shelves a long way away, about 2 or 3 blocks away. Very dramatic, and after he got done, he said, let's do it again. And they did it a second time. Really made a mess of everything. They almost had to junk the whole turbine. Anyhow, what we're going to do here is talk how it is. The front you see turning is a compressor. It compresses the air, and from there it goes in the fire chamber. In the fire chamber they have nozzles, inject fire burn with the compressed air, and it creates a great volume, an explosion, and that turns the turbine, which keeps the whole thing running, and you have a massive amount of exhaust out the back, you know, coming out of here. And that's the thrust. T-R-U-S-T. That's the thrust that you have. Is it T-H? I don't know. That's how the jet engine works. It's very simple. This is how things are made. But let's look at reality. The reality of this is at the reality of this is at on the ground you're dealing with roughly 21% oxygen, O2, and you got controllable. Oxygen is everything. If you don't have enough oxygen when burning, you have incomplete combustion, and this is what it's all about. You have incomplete combustion. But at 10,000 feet in the air, you only have 7% oxygen. That means that blend's terrible. You dump more fuel in it than it was supposed to. As a result, the efficiency goes down. The big E. They noticed this during 9/11. They grounded all the planes, and you know what? We had clean air. And it was because the jet engines were not in existence. The whole idea behind this is to make things better. So these are turbine blades compressing air, goes through here, creates an explosion, increases volume massively, turns the turbine on the end, and the whole thing keeps working back and forth. But let's change things. Let's take some of this heat exhaust and bring it back and put it back in here. At 10,000 feet, pretty close to freezing, 32 degrees. About 32 degrees, roughly guessing. Might even be less than that. So, capture some of the heat and do that. And let's bring in oxygen and put it in through your compressor, raising the efficiency of 25%, which increased the exhaust by a massive if you did that. And this can all be done with just things here. These are blades. Creating more efficient than 21%. And you could do this in the air, of course. And you won't burn as much fuel, because the higher the oxygen level, the less fuel you really need. I welded with acetylene welders. Oxygen acetylene, and when you just burn acetylene, it's yellow flame. But as you turn on the oxygen, the flame kind of recedes, turns blue. And the temperature rises. The temp rises up. And probably you're running around maybe 1800 degrees as a yellow flame, and as you bring in more oxygen, the temperature rises dramatically, and you end up being at roughly, let's say, 3,200 degrees at a neutral flame. And once the feather disappears, you go into add more oxygen, you go up to 36. Now, we talked about changing a matter of water and what it did. So we're bringing in more oxygen, we're compressing it, we're going to use less fuel and get more out of it. It's going to explode. So my fuel level will go down. I won't have to use as much fuel to do the same thing. Very simple to do this. But we were talking about a one-soup boiler. And of course, these are all theories. Take what's left of the heat and then envelope this. Let's say with 3/8 tubing, making a very small boiler at 3,600 degrees. PSI and 1,000 degrees. Because this is small. We don't need this massive boiler to do this. Now, if you do that, you can inject it into the fire chamber along with that, increasing the efficiency of the whole thing, the big E. So dramatic. And you're going to use less fuel, and you're going to be able to make this thing literally grown. You'll have a blue flame basically coming out the end of it all the time with less fuel and using distilled water, of course. So how are we going to do this in the air? Well, saying I'm not going to use as much fuel, I don't need as much fuel in my wings and in these tanks. So I'm going to go with liquefied oxygen. Okay. L-I-Q-E-L. Oxygen. O-X-Y-E-G-E-N. And water. Distilled water. And I'm going to create a mini boiler on the end of this thing. And being in this state, we're dealing with 3,600 psi, and if you caught the first one, you'd understand the theory behind it and what B&W did. They didn't understand what they made, they're just trying to turn a turbine. Massive turbine made by GE. GE makes the best generators and turbines I've ever seen. So this changes everything. And Chuck, my stepfather, told me they made a mini boiler, quick boiler, and low pressure steam, of course, and they're running at 350 engine on this boiler. And this guy took out a gun and shot a hole in it. He's sitting on a boiler while it was running. Took a 45 caliber gun, put a bullet right through it, and the damn thing quit. You know, the engine stopped. Very easy to do this, but instead of being on low pressure, we're going to deal on 3,600 psi at 1,000 degrees steam. And this will change everything. This is something very simple, and it can be done. Now we're talking about the 3,600 psi. And it's not water, it's not steam. What is it? It's the third stage matter. Being that it's not liquid, it's something else. You can spin it. Probably the oxygen would go to the outside. Now I'm going to draw a tube here. Okay. And you spun it. And the oxygen, I'm just theorizing, the oxygen goes to the outside, the hydrogen will stay on the inside. O2 and hydrogen, and separate the two. I don't know if it's possible, but if it's probable you can do this, you can extract the hydrogen out of the center. Instead of burning kerosene, burn hydrogen, and it becomes self-sustaining. You would use the other part to start the whole process in action, but once it's running, it stays running until you run out of water. Very simple, just an idea that it could do this by spinning this matter. You can change something there. I don't know, it's just a theory, it's an idea. Ideas can happen. But we know what 3,600 psi and 1,000 degrees do, and now they make turbines running on low pressure steam at 1,000 degrees. 1,000 degrees and 1,000 degrees, 1,000 psi. Why? We're back to steam engines. They have the most best thing in the world right here. Can be done in nuclear generators. They say that the turbines, they run natural gas, puts out so much exhaust gases they can run a small boiler off it. Again, you could do the same thing. And when the exhaust will come out blue, and I mean it will come out blue, you recapsule it and recycle the water. This is how turbines actually work. There's a reason they have a condenser on the end. It improves the efficiency. Once you can turn it back to water, creates a vacuum on the LP, improves efficiency. But this is a jet engine we're kind of just looking at, and how can we make it better? And this is the whole theory behind it. We can change things, make them better. By the way, you'll have green air. Burn less. You'll burn less fuel. Things will change if you follow through with this and figure out what works and what doesn't work. And these are very important facts, and this is how we can change things. So we might, if this is feasible, we can actually take some of this water we're heating up at 1,000 degrees, and believe me, 1,000 degrees is coming out of the back end, capturing the heat from here, transferring it back, increasing my oxygen, and perpetual motion almost. As long as I got water, the darn thing will run forever and ever and ever. Amazing stuff. You don't want to go to the 4-stage. I think it exists, but it would be very dangerous if that line blew up like that. It would be very dramatic. It just didn't bubble in the center. It ballooned it, and something happened. I don't know what it was, but it does. But these shafts have to turn. When you get on a plane, you see the thing turning, and the reason is warpage. The clearances are very tight in here. You have rotating blades, stationary blades, and this is the way things work. I tore apart that 750 megawatt unit, a 220 megawatt unit, and 125 megawatt units. I've worked on the stop valves, the control valves, pulled the pickles. The LP pickle on that 725 megawatt unit weighs 120 tons. It is massive. And this is how I see things. I do not really deal too much in computers. God gave us the best computer in the world. And it's between our ears. We must use it. Changing the whole dynamics of the whole thing. But this is basically changing the way we live. Oil will become something that we lubricate with, and if you keep it clean, it never goes bad. Those turbines been running on the same oil for 40 years. It never goes bad. And a lot of people don't know how, and they're Babbitt bearings. They're not roller bearings, they're not balls that turn, they're Babbitt bearings. And understanding how a Babbitt bearing works, it doesn't run on the Babbitt at all. Babbitt is very soft material. What happens is you got a cut in the Babbitt, and the shaft rotates, catches the oil, and creates 10,000 psi of pressure, and it rides on a film of oil. If it wasn't that way, the bearing would be eaten alive. Anyhow, this is the whole theory I have on this. Whether or not it's feasible, but at 3,600 and 1,000 degrees, they said jumping from 24 at 2,400 PSI, the energy force increases almost double. Don't know why we're back to doing things backwards. Maybe that's the way man is, you know. Step forward and walk backwards. But this is what it is. I don't change things. I deal in reality, not fantasy. And this is simple mechanics, simple theories. And it's offered to the whole world. And we're going to go on from here, and then we'll go into mechanics and how you can make your engines run better. Matter of fact, it might become fashionable not to have engines. It might become archives, and you'll run on 3600 psi and 1000 degrees steam pressure, and you'll recapture it and start over. Too many countries things are done this way to fight over oil, and there's no reason to it. And can we last with what oil? You know, they got to calculate how many years can we last with what oil we got. This would increase the usage of oil and fuel as we know it. People won't hold on you because you've got fuel. You can do this with atomic energy. Very small setups, turn a turbine, make electricity. The French did it, but they're dealing on low pressure. Now we're dealing on 1000. Might change the whole world. Isn't it better to make things better than make it worse? Theories. That's what it's all about. How to make things better. In this section, we're going to deal with gasoline engines and how things work and efficiencies and all that. The big E, like always, efficiency. You got to think of the efficiency. You know, you buy a car, gets pretty good gas mileage, and then it starts going down, 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 and you go in, they say, your fuel pump regulator is bad. But is it? You gotta understand how it works. What does the fuel pump regulator work on? It works off of vacuum, the vacuum from your intake manifold. When I step on the gas, the vacuum will drop. It'll go down. And when it does that, it closes down here, increasing this pressure here on your fuel rail, goes to your injectors. Like an old accelerator pump on an old carburetor. The more I step on the gas, the more fuel pressure I get to my fuel rail, gives me more go. Old carburetors had an accelerator pump built in. When you stepped on it, big streams came down, get plenty of fuel, you went. Basically the same thing. And this is how it works. And it cuts the pressure down by the vacuum, comes back to your turn. So it's open on high vacuum. and it closes on low. They're going to put some marks here because I don't want to write. Vacuum. This is important. Now, why am I using more gas? Vacuum leaks. The two things people do not realize: your engine is under vacuum. Used to be we had a breather pipe, now the whole engine is under vacuum. They don't replace the O-rings on the dipsticks, which leak air. That decreases my vacuum. And they don't replace the cap where they put the oil. Over a period of time, they start sucking air, or my valve covers start leaking. You know, sucking in air. And they don't replace the cap on my gas tank. That is very important because it all runs on vacuum. If my gas cap is leaking, I'm going to get lower vacuum to this, increasing my fuel usage. You do these simple things. It might not be a fuel regulator, Dad. You might have vacuum leaks. I do it on my. I did it on my truck. On my van. Replace these things. They're very cheap. Save you big bucks. Believe me. A master mechanic had to figure all this out. Put a regulator here and tried lowering it, but the fuel regulator was screwed up because some mechanic got in there, bent my fuel rail so bad my injectors were coming out of my engine, shooting gas all over the place. Terrible. I had to put all new injectors in there. It's a 7.4 motor, massive. That's a 454. And I had gas shooting from underneath there. I found mechanics to be dishonest. The guy split the manifold, bent my fuel rail, and he never got to the regulator, which is up against the firewall. He would have seen that the hose had a hole in it. It was burnt. So that meant it didn't work. Besides that, he took the vacuum hose that came, the line that came off my valve cover, and had it pointing out in midair. And I had vacuum leak here, massive vacuum leaks in my engine. Caused me to use more and more fuel. Cost me about $1,200 for what some stupid mechanic did. Little knowledge, and he didn't even change the gaskets, you know, because my plume is this big. You have to split it. Didn't replace the gaskets on any of it. I found things loose. I mean, terrible. Can't believe it. They did a survey on one guy, and what they did was disconnect one sensor, and they sent it in this mechanic. And this mechanic, they had it on film. He just hooked up that sensor, but he did so much more to it and charged him $1,000. Had him on film doing it. This is mechanics today. It's a Punchme act to screw the customer over and over again. Knew one guy took it in for an oil change, and while he was at oil change, went out for a cigarette, and by that time he'd already put another can of Freon in his air conditioning. Every time the guy put on his air conditioning, the engine started going, ugh, because it did not have, it locked up the air conditioning compressor, and of course it would not cool the car as well. But he said, oh, do you need to have that air conditioning check? Really. The guy drove around for 2 years doing this. And I had to redo his whole air conditioning as well. I saw it had 300 pounds on the high, over 300 pounds on the high side. I bled it all off and recharged it, and did the whole thing all over again. Finally got it down to about 35 on the low side and around 225 PSI on the high side. Watch it. Took my car in for a free air conditioning analysis. He had so much Freon, and I had 35 pounds on the low side. And this was free. He had the damn thing locked up so bad, it was incredible. And they said, "You need all new belts." I said, "Really? A dealer just put all new belts on." So, oh, that's a different car. And then he came back, "You need this, you need that." And the price just kept going up and up. And finally, I just laughed. I said, "You know, I'll do it myself." And I did it all myself. I'm very good mechanically. I don't need manuals. I can take them apart and put them together and figure out what it does. So basically, fuel pump puts out about 60 PSI, comes here to your fuel regulator. If I'm high vacuum, a return line opens up, dumps the gas back. I got about 42 PSI. But if I step on the grass, it jumps up to, say, 57 PSI. More fuel to my injectors, increasing my speed. Very simple to do. Anybody can go down and buy a new oil cap. A new oil cap. Leakage around my dip. DIP-STICK, which checks the oil level in my motor. And check for vacuum leaks. Replace the fuel cap on my tank, because everything works on vacuum in all cars. The more you lose vacuum, the more pressure you're going to have here, increasing your gas mileage will go down. Very simple stuff to do. And basically then we'll go on to another thing. I'll leave that out there so you understand what it does. Very simple stuff. And we're going to go on to a different subject. Something I really like, and been around for many, many years, STP. I don't know what it does in the Ninja. I don't use it for that. Good on ORINGS and seals. And putting things together. I mean, the slickest substance I know, and I use it. I got a container of it, and this is what I use it for. I got a little brush, I put it on O-rings. Now, where I can't get the damn O-ring in, put a little STP and the damn O-ring will disappear. You'll think it fell off. It just slips right in. Seals might be good in the oil to lubricate your seals. I've seen it where an oil seal, draw a shaft and put a oil seal, and it's got a little lip. Well, it might even have a dust ring. But I seen it cut holes in the shaft. We had a sleeve. If that happens, you have a very thin sleeve, slides over the whole shaft. You can buy them. And they're open. They usually have a lip on it. Slide it over. Break off this. You repair the shaft, which has a dent from the seal. Might even improve there. Use it constantly when putting stuff together. Anything with the seal or rubber, it is great. Probably might even help you lubricate your motor, and does wonders. I mean, I use it constantly. Me and SDP, nothing like it. I put it in my pipe dope. PIPEDOPE, because people don't know how pipe fittings work. You got threads on the pipe. It's a combination of pressure of the two threads coming together that actually seals it. It isn't the pipe dope. It isn't the pipe dope that seals it. It's the bonding, because these are tapered. When you put them together and it get tighter and tighter and tighter, it's here that actually seals. Knowing that, it'd be good in pipe dope. Very good lubricant. You got to be careful, because if you do this, put it on bolts or stuff, you can over tighten them because they really slide easy, especially if you're doing torque. You got to kind of compensate a little bit. And from there, we're going to go on to a different subject. SDP, best things for O-rings and seals. Use it constantly in mechanical work. In this segment, we're going to talk about changing oil. I change oil different than anybody. What I do is I drain my oil, I spin off my oil filter, and I dump the oil, drain the oil out of the oil filter, the old oil filter. And then I fill it full of diesel fuel and spin it back on, and I put the diesel fuel to the right amount, to the full line of, put my plug back in so it doesn't drain out, of course, and put diesel fuel into the proper level as oil. I also remove my spark plug wires and pull my plug wires, and the reason I pull my plugs is so I don't have any compression. Then I'll go in and just crank my motor. What you'll have is when you drain it all, you'll have very dirty diesel fuel. Of course, you're going to capture that and save it, because you can use it over and over and over again. And if you have a filter system, you can always filter it. What makes oil dirty is carbon left over from combustion. If you're running natural gas or butane, your oil never gets dirty. It's only with gasoline, and it's caused by carbon. By doing this, you clean the outside of your car, clean the inside of your engine. It would be much, much better. I did it on a Harley Davidson. I could smell the diesel fuel, the diesel smell coming out of the cylinders as we cranked it. Meaning it also cleaned all my rings. We drained it all, spun off the old oil filter. Harley Davidson, you can't put oil back in the oil filter. You spin it back on, put the plug back in, filled it back up with oil. Thing runs dramatic. We also did it on a standard transmission and a rear end. Cleaning things is very important. makes the inside of the engine almost new compared to what it was. And from here we're going to go on to talk about octane. O-C-A-N, octane. I think it's got my spelling problem. Octane. You got 87% octane. 91. Goes on up. This be regular and premium. What is octane? Octane is about combustion, and that's what it's all about. When I was a kid, it was pretty common to run into regular. It was 120 octane. Octane is about combustion. If you looked at raw gas, plain raw gas, I'm going to draw a circle. See, some of them are big molecules and some are small molecules. Some are red, some are white, different sizes, different colors. And, draw some different shapes in here. And they're all different. As a result, what happens is the red ones are going to ignite easier than the white ones. And the blue ones. It's about octane. Octane is the amount of combustion, how it explodes in the cylinder. Everybody heard the engine knock, 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 knock. Octane level was not efficient, needed a higher octane. So these numbers deal basically and the rate it'll burn. So my car costs for regular, I'm going to get more out of it. It has nothing to do with BTU. And BTU is a British thermal unit. It's the amount of energy to take 1 pound of water at sea level and raise the temperature by 1 degree. That's a BTU. Everything is rated on British thermal units, electricity, everything. So we know that this has the same BTU as this. The only difference is this has more to it. Why did they add lead to gasoline? Everybody says, well, it lubricates your valve stems. Really? They don't lubricate my valve stems because we don't use lead. L-E-A-D. What did lead do? It made them all red. All these things were red. Colored the gap, the molecule structure. There's no more white anymore, no more blue, They're all red now. So they ignite at the same rate. They absorb energy at the same rate. So I raised my octane level up with lead, and that's how I went from 87 octane to 100 octane. Now this is how it worked. And that's why of course, I read the book on it. The guy, they said we tried thousands of different combinations to get to lead. He said the best was iodine, but the motor only lasted 8 hours, and that was it. So lead is a very we don't have lead anymore. What did they do? They ran it through a cracker. And all the molecules are now basically the same size. Additives and stuff like that, things that aren't lead. But all the molecules are the same size. They broke down the gasoline and it gets a lot less And of course they charge you arm and leg. Now back then, when they added lead to the whole thing, all gasoline had diesel fuel in it, a certain amount. But they couldn't run the diesel fuel through the cracker. And the cracker just kind of forces it through very fine screens, break it down, basically. So they ended up with less a barrel of oil doing it the old way. Let's say they got, let's say 28 GAL of gas out of it. But now they don't get 28 because they run it through a cracker to break it down. So now it's only getting 20 gallons of fuel out of barrel oil, which they're charging more and more. And of course, they couldn't run the diesel fuel through, so they had to remove all diesel fuel. But they kept the diesel fuel and charged you for it anyhow. So everybody, diesel trucks, diesel trucks. Well, they only invented diesel trucks because they had so much diesel now, because it wasn't in the gasoline. This is how things are. They did a Plumbing Act, they got the diesel out, they kept the diesel, charge you more for the gas. Dollar signs. That's what it's all about, dollar signs. Gas has less BTU than diesel. I'm just going to put the D up there. Diesel fuel. F-U-E-L. So not only are you running on just plain gasoline, you have no diesel, which would increase your BTU, so you get less power. And it wasn't uncommon for the compression to be 120 PSI on your piston, in your cylinders. But saying they couldn't do that because of the Clean Air Act, now you run maybe 85 PSI versus that. And now they got turbos that actually raise the pressure in the cylinders, trying to get more efficiency because you get more oxygen in there. Higher the oxygen, the more combustion you will have. Of course, you have to add more fuel in there to do everything, to keep things cool, because when you do that, the temperature goes skyrocketing. So this is octane. This is how octane is. Not a very good speller, but this is basic stuff. It's how things work. Because I sat down and talked to a guy that worked at a refinery. He explained all this stuff to me 20 years ago. And this is how things are. So if it calls for regular in my car, I'm putting regular in because it's cheaper. CHEAPER. It's much cheaper to run 87 regular, and I won't get anything more if I go up on my octane level. If it calls for high octane, run high octane because you'll destroy your motor running on the cheaper shit. I run a certain amount of diesel fuel in with my gasoline. Why did I do that? It increased my efficiency of my engine dramatically, and the power went up, up, up. The power. P-O-W-E-R. Like I said, I run a 7.4 motor. Running regular gasoline, I get about 9 gallons per 9 miles per gallon. But if I run a little diesel in there, I'm up to about 11.5 miles per gallon. And power that you cannot believe. I can step on the gas and be doing 75 miles an hour in a split of a hair. Raise the efficiency, get more power. I'm running probably about 5%. You know, I'm still playing with it. 5% diesel in my gas to 10%. You can tell by exhaust pipe, if it's getting black, you got too much diesel. And from there, we're going to talk about catalytic converters and what catalytic converters are. Being a master sweep, dealt with wood stoves that ran on catalytic converters. And to understand what a catalytic converter does is very important. We're going to talk about catalytic converters. C-A-T, cat, L-I-C-V-E-R-T-S. Catalytic converters, probably spelled it wrong. I'm just going to put catalytic converters. And being a master chimney sweep, we had catalytic converters on wood stoves. And basically, I tested them. And what I do is I take a cat, and I didn't know if it, and I had a stove on my truck to check the cats too. I had a regular burner. And what you do is, you gotta, on a wood stove, you gotta bring it up to about 600 degrees. And once you get to 600 degrees with the fire going up through the cat, let's make a little bottle here. The heat going through, you shut off the fire and just bring on the gas. This temperature would raise up to, let's say, 1200 degrees. No fire. Actually burn the fuel with no fire. The cat would start glowing red, no fire. And the temperature would go up, up, up. If it didn't go up, 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 and started going down, 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 I knew the catalytic converter was no good. If it only got, they said don't go over 1200 degrees. I've seen them go as high as 1600 degrees. And this was important in wood stoves because the smoke would come up, go into the catalytic converter. You had a open damper and a bypass damper, and when it went through the bypass damper, all the smoke would go through the catalytic converter, which is honeycomb ceramic, just like a car, and it would ignite, but in the presence of oxygen. Oxygen is a big thing. O2. Without oxygen, the catalytic converter does absolutely nothing. And if you were around when they started putting catalytic converters on cars, what they did was that they had a pump. And the purpose of the pump was to pump air into my exhaust manifolds. You know, say it was a four-cylinder, pumped air into it. After combustion, and this all joins together and goes to my catalytic converter. So I'm pumping oxygen after combustion. Without the presence of oxygen, the cat will barely work at all. I mean, it won't ignite. You got to have oxygen in there to do that. So that's Oxygen is a very important thing. But we don't have pumps anymore, so I don't know what the catalytic converter actually does. Basically, most of it is controlled by fuel injection. Only the United States did not put fuel injection on their motors. The rest of the world was running on fuel injection. We had regular, ordinary carburetors. They tried many different things. But this is how a catalytic converter works. We do not hear air pumps anymore on cars, and I think the efficiency of the cats have probably dropped. They said the cats on a truck, if you pulled up in a grassy area, they were putting out so much heat, it'd catch the grass on fire. You know, if it was touching, it would catch the whole thing on fire. That's how good they were with the air pump. Don't know how efficiency they are now. Same thing where, I put lacquer thinner or something in my gasoline so it makes it didn't work any better. Increase the air in your exhaust gases. It will work a lot better. Raising the oxygen level will increase your catalytic converter to work even better. And you know, if you did that, and you might never ever have to replace. I've seen catalytic converters plugged. You know, took one off a car and put water in it, and no water came out, which is like sticking a potato in your exhaust pipe. You know, no power, no airflow. You got to have exhaust gases to come out. I just knocked it out, and then they said, well, we got to have it back, so I put a new catalytic converter on to convert it back to catalytic converters. Took me a long time to figure out that Bronco 2, what a piece of junk. It had a carburetor on it. I mean, I was dealing with, went in, you'll see a wire in the old cars, and it had a little plastic rubber tab off it. And this is a fuse. If you pull this and the thing comes apart, the fuse is blown. I found that on the computer, and it controlled, I think, 27 pins. So my computer wasn't working at all. Had a problem with the motor dying, you couldn't crank it. I had a lot of problems. I found all the problems, and it finally wouldn't crank. I said, send it to the dealer. And what I found out was, I thought about it, and I came back out, pulled the plastic holding away from the ignition switch, and I found that where they stapled it in, riveted the wire line in, it was broken loose, and as a result you were getting contact, no contact, contact, no contact, and that caused all these other problems in the wiring, you know, the pins and everything on the computer. And finally I found a vacuum hose that was busted off. It controlled all the vacuum things as it went to everything. Real piece of junk they made. Very important to know how catalytic converters actually work. You got to have oxygen too, and this is nothing but a gas coming up, burns completely in the catalytic converter to all the different honeycombs, they call it, through the ceramic, with clothed with platinum and palladium, different things. Some dumb person says, oh, they're worth money, and everybody ran around, all the junkies ran around with saws cutting off catalytic converters, which were worthless, caused much damage. Someone, what a punsy thing. But this is how a catalytic converter works, and I had to know this for wood stoves. Being on a car now, we do not have air pumps. It would be better to put O2 back, or air back in your exhaust, and that would go to your catalytic converter. Some catalytic converters even had a line to add the air in. It was hooked to the vacuum pump, you know. But you have to have oxygen, O2, in there to make the damn thing work. I don't know, because they put them on there originally, they got to put them on there again. Seems like they never go bad. You know, they burn a little bit, but not like they used to. I seen, you know, a video about this, but he really did not have the knowledge of how catalytic converters. It's a flameless heat. You will not see a flame. It can get so hot it will reignite the burner underneath. This whole thing would turn red. Go up to 1600 degrees, and they said don't go over 16 because you burn out all the platinum and palladium. And they're basic things in wood stoves. Then they came up with different ideas. Everybody thinks when you strike a match, you see the match, the fire. It's in the presence of heat. It breaks down the molecule structures of the wood or the paper and produces a gas. And what you're seeing is the gas coming off the paper or the wood. And this is basic technologies. Master sweeps should know it. And I'm not going to go into wood stoves because I can draw a whole bunch of pictures of how everything works in wood stoves. Basically, this is how a catalytic converter works. And you'll have it on your car. Same thing, honeycomb thing, but longer, where they're pumping the fuel through. Your exhaust gases coming out of your motor. But we don't have the air pumps anymore, so I really don't know what they actually do. Very little probably. Most of it is controlled by your injectors now. But if you put air in it, it would raise the temperature of your catalytic converter. And if you say, well, my cat's no good, well, maybe you need to put some more air in there. Good thought. I've been looking at doing it on my cars. Raising the clean air, you know, that are put out. Heard different theories on it. Well, of course, they're all wrong. Oh, it turns into an acid. Well, it didn't really turn to an acid. It's all about temperature and oxygen. The more oxygen you got, the higher temperature you'll have, the greater it'll burn. I welded with oxygen acetylene, and I talked about it. And I'm going to take a minute and talk about oxygen acetylene and how things are. I'm going to write a C here for acetylene. I think it's spelled with a C. And I'm going to put O2 here. This is a fuel. Just turning the flame on. You got two handles here. This is fuel. You know, and this is O2. Goes to a mixing chamber, and you're just running the fuel, and what comes out is a yellow flame. Probably around 1800 degrees, maybe less. Never really measured it. But adding O2 to it changes the whole dimension of the fire. And what you'll have it'll turn blue. You'll have like a funnel, and then you'll have a feather, what we call a feather. And by doing that, by putting more O2 in, you bring that feather to this point, and you'll end up with about 3,200 degrees, or a neutral flame. I'm going to just put it in here, neutral flame. But if you increase it, you'll get up to 3,600 degrees, and it'll be oxidizing, a lot more oxygen. You add more oxygen, the fire goes out. And that's basically how it works. But at 3,200 degrees, I can weld mild carbon steel, which is roughly about 60,000 tensile strength. Tensile strength, H. It's tensile strength. Any higher than that, really, you can't weld it. Not with this. Because it changes things. Well, what I just do is take a pipe and give a demonstration. I heat that cherry red just to the point where the metal was flashing to a puddle. I shut off the oxygen and just hit it with plain carbon. You know, the carbon flame. Just this, the fuel flame. Black. You know, you couldn't touch it with a file. Changed the whole characteristics, hardened it totally. When they call it flame hardening, that's basically what they're doing. They're changing the characteristics of the metal, turning to a harder thing. So anything that would be like a wear plate or something, it has a lot of carbon in it mixed with the metal, which makes it very hard to wear. I couldn't even touch it with a file. File's pretty tough. I can cut stainless steel with a file. I couldn't cut that. And I'd do that for a demonstration, because if they ran the feather, that's putting carbon in the metal, making it hard. If they're running at 3,600 degree, you're burning the carbon out of the metal, and versus it becomes crystallized. This, you couldn't bend it, won't last in either direction. So you had to have a neutral flame to do the job. Very simple stuff, but I taught how to weld settling quite a bit. Everybody talks about cutting with a cutting torch, cutting metal with it. And the idea behind cutting metal with it is you got heat, and I'm just going to draw an area. If you look at the end of a cutting torch tip, you'll see, and what you have is a cutting torch, a mixing chamber, and you'll have here for your oxygen so you can control your flame on the outside. But you have a handle. When you hit the handle, oxygen comes out, and it's actually a rusting process. And it literally rusts the metal in two, and it does a very good job of it. I've seen 5-inch steel cut with a number 4 tip. Matter of fact, I've done it inside pulverizers. Just heat it up and cut right through it like it's butter. But it's a rusting process. It rusts heat in the presence of oxygen. It's a rusting process. It blows right through that piece of metal, a fine line. Of course, you shake, and of course, the line is all crooked. You're not pulling the chalk line, and it gets crooked. But it's a rusting process. And the slag shows that it has gone away with the carbon. Very dramatic way of doing things. But knowing this is basic stuff. Everything has to have oxygen to work. If you don't have oxygen, it's not going to burn. If you're in an inert atmosphere and you light a match, it don't burn. There's no oxygen. So oxygen very important in many ways. The amount of heat. We're talking about natural gas. Natural gas burns on your stove or in your furnace at 2700 degrees. But in the presence of oxygen, it'll get to 3200 degrees. Big difference. Oxygen has a lot to do with burning, how well it burns. And this plain simple thing, I took a guy who never acetylene welded in his life. He did a horizontal and a vertical 2-inch weld, and he passed it by teaching him simple bland marks. I said, well, I watched him, and I said, well, go back to your test coupon, I went back and I showed him what he was doing wrong, and he passed the whole thing. Never acetylene welded in his life. And we cut the coupons out and bent them, and they were good. 100% weld, showed him how to do it in roughly about 2 hours. One thing when you're welding, let's draw a line here, and you're settling, right? And you got a puddle here. You filled it all out. All of a sudden, you've got the endless hole in the middle of the puddle. You can see right almost through the pipe. And you're trying to get rid of that hole, but you can't. You can't leave it, so you're adding more and more metal, which makes it even worse. The only thing you have to do, I'm just going to draw a tip here, is heat it up. Get that puddle flowing till that thing's starting to kind of make a circle around, it's making a circle. It's not staying still anymore. Pull the torch away, and it disappears by not having it. And it'll pass an x-ray. It'll pass an x-ray. They don't like x-ray acetylene welds, but it'll pass an x-ray. Because it looks different on the films. Of course, we can also go into plasma arc and how plasma arc works, and I taught it. He ran a thermal arc. It would cut 5-inch steel. Amazing. 2 inches of aluminum, which is really amazing. So this is basic, talking about catalytic converters and how oxygen is the big key to everything. O2. If you don't have oxygen, things don't work. You have to, in space, you have to have oxygen and fuel to make the damn rocket work. If you don't have oxygen, you can dump all the fuel out, but it won't burn, it won't ignite, it won't go anywhere. Just go out in space, and you'll have a big old void of fuel laying out there. But in the presence of oxygen, everything happens.